Dear students, welcome in chemistry. We know that in our textbook for your future exam, at least 4 questions they have asked to us in future and the past exam. At least 4 questions they will ask from P-Blok elements. We are studying here all P-Blok elements and its property, because from 13 to group 18, you know that group 13 to group 18 is P-Blok elements. We are now preparing about C exam, NEET exam, and also CUSET. So, what is the definitions of P-Blok elements? We know that in any atom, in last orbitals, electron filled in p orbitals. We know that also there are 3 p orbitals, px, py and pz, and total maximum 6 electron we can fill in p orbitals. So we know that the common electron configurations of P-Blok element is ns2 np1 to 6. We know that group number 13, 14, 15, 16, 17, 18. There are 6 groups in P-Blok elements, and each and every have 6 elements. As for example, group number 13, boron, aluminium, gallium, indium, thallium, and you know that neodymium. Neodymium is radioactive, very small amount present in nature, so we know about neodymium. Similarly, 14, carbon, silicon, aluminum, tin, lead, and fluorocarbon. Similarly, nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. So, you know that all 6 by 6 there are 36 elements. Out of these 36, the last one, the 7th period, totally belongs to radioactive elements. So we know that what happened in this one, how we remember symbols and atomic numbers. Each and every, the next sequence elements have the difference 8, 18, 18, 32 and 32. As for example, you know that carbon have 6, plus 8, 14 silicon, plus 18, 32 germanium, plus 18, 15, plus 32, also lead, plus 32. We know that 14 is a rhodium. So, similarly happens with all elements in the same group have the atomic number of the difference 8, 18, 18 and 32, 32. Now, we know about the electron configuration. By the electron configuration, we know that the group number 13 have electron configuration ns2 np1. By the group 14 have the electron configuration is ns2 np2. Similarly, 15 has ns2 np3, 16 has ns2 np4, 17 has ns2 np5, while the 18 has ns2 np6. We know that some difference between when the difference is 18, 18, 32 and 32, there are d and f orbital will take place in electron configuration. So we know that here the difference between aluminium and gallium is 18, have the d orbitals in gallium, while there is no electrons in d orbitals in aluminium. Similarly, with indium, the difference gallium and indium, you know that 18 for the folding, But when the difference will come 32 have the 4f and 5f orbital electron configuration with the elements. So the electron configuration, you know that same electron configuration has the common electron configuration, the ns2np1, ns2np2 up to ns2np6. So this one is the periodic property. With difference 8, 18, 18, 32 and 32 have the same electron configuration will come in the next elements have same ns2np1, either ns2np2, similarly ns2np6. But something is different when the difference comes at 18, 18, 32, 32 have 3d orbitals, 4d orbitals, 4f14, 5d10, 5f14 and 6d10. The last electron configuration also have the same 4s2, 4p1 to 6. Similarly 5s2, 5p1 to 6. Similarly 6s2, 6p1 to 6 and 7s2, 7p1 to 6. So the concept as a electron configuration is a periodic property. Now it is clear. Another one is the periodic property is covalent radius or atomic radius. We know that when the electron enter, the last electron enter in boron, have the orbit is 2. Similarly, when we increase in the atomic number in the same group, what happen? Suppose this one is our nucleus, have orbit 1, orbit 2, orbit 3, 4, 5, 6 and 7. So what happened in this sequence? You know that in boron, the last fifth electron in second orbit. Why? Aluminium, third, gallium, indium and thallium. So by this structure you know that the atomic radius or covalent radius will increase. So what happened? This one is a periodic property. From left to right, radius will decrease. From top to bottom, radius will increase because the new elements have the new orbit, the new cell. Second, third, gallium is fourth, indium is fifth, sixth, and seventh. Happens with all groups. So sometimes have the slightly different. As for example, regularly aluminium has less atomic radius with respect to gallium. But here is the difference that gallium has less than aluminium due to shielding effect, due to weak screening effect. So this one is also the same property in any group. If the atomic number is increased, always covalent radius and atomic radius increase. The third one, periodic property is ionization enthalpy. The definitions of ionization enthalpy is that in a neutral gaseous form of any elements, if we want to remove one more electron, because the unit of ionization enthalpy is kilojoule per mole. For one more electron, when released from the atom, I would say gaseous state, the required energy is known as ionization enthalpy. By the definition, we know about the ionization enthalpy can be defined as, again we say that for any neutral gaseous atom, required energy to release one more electron is known as ionization enthalpy. So we know that from in the sense of periodic property, the ionization enthalpy from upper to bottom always decrease. Why? Because the last electron, suppose here is the boron, aluminium, gallium, indium and thallium. Distance between nucleus and last electron will increase. Attraction will be decreased between nucleus and last electron. So if we want to release this electron, the attraction decrease. If the attraction decrease, the required energy is also decrease. So from top to bottom for each and every elements of same group, from boron to thallium, carbon to lead, nitrogen to bismuth, oxygen, polonium, fluorine to astatine, while the neon to radon always decrease. So the ionization enthalpy is also a periodic property for same sequence, same decreasing in each and every group's elements. Similarly, another one is electronegativity. What is electronegativity? Electronegativity, we know that with reference to lithium's atom, electrons of another atoms attract by the nucleus. We know that this one is electronegativity, but no unit because this one the comparative with lithium. So we know that when the distance between the another atom's electron, the distance will increase, so the attractions toward nucleus will be decreased. So what happens? From top to bottom, electronegativity is always decreased because to attract another atom's electron from nucleus to another atom's electron, the distance is higher. If the distance increase, the attraction will be decreased. In the sense of electronegativity, for each and any group always decrease. The most important is oxidation state. The oxidation state is most important. Why? So many properties depends upon oxidation state, like acidity and basicity, like ionic nature and covalent nature, like strong oxidizing agent, like stability. These all properties are depends upon oxidation state. So we know oxidation state. Oxidation state also depends upon electron configuration. Here we know that NH2NP1 from group number 13, boron family, have +3 oxidation state, because the last electron from 2 NH2 and 1 from NMP, there are 3 electrons will release during the reactions, have the positive +3 oxidation number. Similarly, 14 have NH2NP2. In the initial, carbon and silicon have +4, while the tin and lead also exist +4 and +2, because the atomic volume is increased. So the last 2 electrons of Pp from 6p2 from indium 5p2 will separately release from the atom. So what happened in this one also we get a stable form +2 or +2 oxidation state, while the group 15 NH2 and P3 for nitrogen and phosphorus active as a nitride, active as a phosphide, have the -3, while the arsenic antimony bismuth have also +3 and also +5. Similarly, oxidation state of 16, oxygen and sulfur, what is the oxide and sulfide, have -2, while the selenium, beryllium, polonium have also +4 and +6, because this 4 electron of p orbitals, and while the 2 also 2 and 4, both 6 4 electrons are released from the atoms. If the strong electron negative elements like chlorine and oxygen, when come to nearer selenium, beryllium and polonium, have +4 and +6 oxidation state can be obtained. Similarly, halogen group number 17, chlorine, bromine and iodine, have -1 because they want to accept one electron and complete a inert electron structure NH2 and P6, so it required one electron to have -1 oxidation state, while also when they react with higher electronegative elements like oxygen and fluorine, they gives +1, +3, +5 and +7 oxidation state. Similarly, neon, argon, krypton are inert gases. They doesn't react with any elements, but high electronegative like chlorine and oxygen, they will give +2, +4, +6 and +8 oxidation state. The most important is that oxidation state depends upon so many properties. Depends upon oxidation state. As for example, we know that oxidation state is the most important property. There are so many properties depends upon oxidation state. Like in short, we say if increase in oxidation state or oxidation number, acidic property is also increased. Acidic property of compound increase. As for example, suppose we take boric acid, H3BO3, perchloric acid, HClO4, sulfuric acid, H2SO4, nitric acid, HNO3. You know that here oxidations of boron, chlorine, sulfur and nitrogen are +3, +7, +6 and +5. So when the oxidation state, oxidation number is increased, substance acidity is also increased and basicity will be decreased. So the lower oxidation number with metal like Na2O, like Ca2O, CaO have the +1, +2 oxidation number, have the basic property. Here is +3, +7, +6 and +5. If the oxidation number is increased, therefore acidic property of substance or compounds also increase. We know that another one is the importance property depends upon oxidation number, covalent nature. If the increase in oxidation number, covalent nature of substance increase. The covalent nature of substance is increased. As for example, SnCl2 is ionic, while the SnCl4 is covalent nature. Because SnCl2 have +2, stable cells +2, and here is +4 oxidation number. So, difference between ionic compounds and covalent compounds, we know that the melting and boiling point of ionic compound is higher than the covalent compounds. So, the another one is important property is oxidizing agent. If the increase in oxidation number, also strong oxidizing agent property is increased. Have the strong oxidizing property. If in any compound increase in oxidation number have the strong oxidizing property, you know that MnO, MnO2, MnO4 have the magnesium +2, here is the +4 and here is the +7 oxidation state. So if the oxidation number is increasing, working as a strong oxidizing agent, because oxidation number is positive charge is also increased, they received electrons strongly. From the Lewis acid theory, we know that any compounds received electron pair having the higher positive charge working as a strong oxidizing agent. And the last one is stability. We know that stability if the oxidation number is increased, the stability is also increased. As for example, K2MnO4 while the KMnO4, here manganese have +6, manganese have +7. The stability of KMnO4 is higher than K2MnO4. If the oxidation number is increased, always stability is increased. So you must have remembered if the increasing in oxidation number for any compounds of P-Blok elements, like they are hydride, they are halide, they are oxide, they are oxoacid, this all property applied for that compounds. If increase in oxidation number, acidic property is also increased, covalent nature is also increased, working as a strong oxidizing agent, and also stability is increased. Thank you.